Hey, so in this lecture I want to discuss how we can get a pointer to the character array that is managed by a standard string. So for this example I have a standard string str initialized to hello human, and then one of the functions that we can use is c_str. Okay, so I do the standard string str dot c_str, and that is going to return that pointer. Now it's going to return a pointer to a character constant. Okay, so because of that I have a pointer ptr, which is a pointer to a character constant, and then I go and print that out using ptr. Because ptr is a pointer to a character, remember the stream insertion operator is overloaded to work with that and will print out the string. If I build a run, prints out hello human. Another function that we can use is the data function, but before I get to that, I would like to note that of course we cannot go and do something like this, use the subscript operator on ptr to change maybe the first character in the managed array. The reason being is that, again, we have a pointer to a character constant here, okay? And the same thing if I change this to data. You can see that also returns a pointer to a character. So if I build a run, we get hello human. But I would like to note that this currently returns a pointer to a character constant. And if I go to my project properties and I change that here, the C++ language standard that the compiler will enforce. Currently that is set to C++14 at time of recording, so you can set that to C++17 or C++20 for example. Click apply, click OK, and then if I do Ctrl spacebar again with my typing character between the parentheses, you will see that now returns a pointer to a char instead of a pointer to a character constant. So I can assign that to over here, to the pointer. And again, because that pointer is const, I cannot do this. But if I have that simply be a pointer to a character, so it's not const anymore, then I can assign some other character to that first element within the array managed by the string object. If I build a run now, you can see I actually get a modified version of that string printed out. Okay, so that is a quick look at that. How to get a pointer to the character array managed by a standard string, and that is using the data member function and the c_str member function. So those two are basically the same. It's simply that in the latest versions of the data member function, that will actually allow you to return a pointer to a char as opposed to a pointer to a char constant. If you look at your reference such as cppreference.com, you have the data member function. You can see how it has been updated. The data member function since C++17 returns a pointer to a char as opposed to a pointer to a char constant. And since C++20, basically the same thing, but now it is const expression. So again, it's important to find a reference to check if the function still works and sort of returns what you may expect, and if there are any important changes that you need to take into consideration. We'll use the data member function in the next example. So I have a string1, string2. String1 is initialized to hello human, and then string2 is initialized basically as a copy of string1. Both of those should store the hello human string. And then I have two pointers here, pointers to characters. For pointer 1 I do string1.data, and for pointer 2 string2.data to initialize those pointers. And then I want to print those out. So I'm gonna switch over to a bit of an exercise for you. Basically what we want in these console output statements is the address of pointer 1 and the address in pointer 2, right? Again, those pointers store addresses and we want to print those out. Basically this is what we want. These are just for demonstration purposes with our knowledge on arrays. Basically what we want is the address of the first element in string 1. And of course for the second statement we want the address of the first element in string 2. Of course, this is not going to give us what we want. If I build a run, you can see this actually prints out the strings. So what I want you to do for an exercise, and actually I'll just remove this here because this can be confusing, is again I want you to get the addresses in those pointers. And once more, if I build a run with this here, if I build a run, again it will print those out, which is not what you may expect since these are pointers, again, that store addresses. But because those pointers are pointers to characters, again, the stream insertion operator is overloaded and will basically print out the string instead of the address of that pointer. So I want you to try as an exercise with your knowledge on pointers to fix this issue. Don't worry if you can't do it, just give it a shot. And when I'll come back, I'll show you how to do it. Okay, I'll just continue on here. Remember, these pointers are pointers to characters, and because of that, again, the stream insertion operator is overloaded to work with that, and thus it will print out that string that is managed by those strings. So what we can do is we can change the type of the pointer to something else. Let's say we do a pointer to void for each one of those. Okay, so there are no longer pointers to characters, they are now pointer to void. And if I build a run, we now actually get those addresses. The address is long because this is x64, not x86. So I have more bits, and thus the address is a bit longer than in some of my previous examples, but you can see the address is different. Okay, those addresses are not the same. And basically the point of this demonstration and this example is that those are different. Every string, string 1 and string 2 will manage its own character sequence or character array on the heap. Just because you do a copy does not mean that those will point to the same string on the heap. Okay, it is not a shared pointer. These are objects and each manage their own array on the heap. One way of fixing this issue, when you want to pass a string to a function or something like that to save memory, because these strings can be huge of course, then what you can do is to make this string a reference. Okay, so string 2 is now a reference, one alias for string 1, and then of course these addresses should be the same. Build a run, and you can see that those addresses will now be the same, because it is the same object. String 2 again is a reference or an alias for string 1. Alright, so that is going to wrap up this lecture. I just wanted to show you how you can access, that is get or return a pointer to the character sequence or array that is managed by a standard string.